I did want to go through one question from start to finish together with you before we move on to anything else so that we can really make sure we understand mean, standard deviation, and how it's used. So in this case, you're the manager of a computer company. You sold 2 computers, you have 15 computers in the back, but you found out that one of your employees, who will soon be fired, stuck 4 broken computers in the back. So out of those 15, 4 of them not good. If your client gets 2 good computers, you won't lose any extra money. You'll just be paid what you were already paid. If your client gets 1 bad computer, you're going to lose $100 in the extra shipping cost. And if they get 2 bad computers, then they're going to cancel their order and you lose $1,000. So first thing we would do is, of course, make a tree diagram. Now this tree diagram, of course, helps us to find all of the probabilities, so that the first one works or is broken, the second one works or is broken. And again, notice that the second time around there's 14 computers instead of 15 because it's conditional. Now I didn't have to make a tree for this, but what ends up happening is most people only count the 0.2095 one time, because they take the probability of a good times the probability of a bad, and then they shortchange themselves essentially. So there is 2 different ways that I could get 1 good, 1 bad computer, which is that it works and then it doesn't, or that it doesn't and then it does. These are the values that I'm going to use moving forward. So what I would like for you to do is, now from here, I want you to find the expected value and standard deviation. You can use StatCrunch or your calculator, and then be ready to interpret the results of what that means. So press pause. Enter these values into your calculator. I'm going to let you figure out how to do that, and then press play to check your work. So again, the way that I put this into my calculator is, this was if I had 2 bad computers, which was -1,000. The probability of that was 0.057. If I had 1 bad computer that was losing $100, that was the 0.419 that we found. And then if I had no bad computers, that was the 0.524. Again, those values all from this tree diagram. From here, then I just let my calculator do 1-bar stats. And again, the 2 that I'm caring about here are my expected value and my standard deviation. These are the 2 I care about. So what does that mean? Well, that means that we expect this mistake to cost us $98.90. Cost us because it's negative. On average, our standard deviation is $226.74. It's kind of large because the large range of possible values, so -1,000 up to 0. So again, we could do more talking about the empirical rule, but essentially this is how much we're expecting to lose. About $99 is what we expect to lose with a standard deviation of 227.